So we're doing question 2 of volume of prisms and cylinders, the harder questions. And the first one says a new building is designed as a compound shape with a floor plan as shown. So you've got the basic end shape there, and then the key information, the height of the building will be 43 meters. So that's going to be the length of our prism, and they've drawn a 3D representation of the thing. So it's a prism because it's got the same end shape, and we've got to work out the volume of the whole thing. So it's just going to be the area of that, whatever it is, multiplied by the 43. So I'm just going to get onto my sketch pad and do that. So I've drawn the end shape that I've got to figure out the area of, and I've just written in the information that the height of the building is 43, so that's going to be the length of our prism, in other words. Now, so what we've got here is a kind of square and a circle, but they overlap each other. So what we need to do is to think of this as the square plus 3/4 of a circle. So I'm just going to write that out. End area equals square area plus 3/4 of circle area. So that's going to be 26 meters times 26 meters for the square, and then 3 on the top, 4 on the bottom for 3/4, and then times for of. So it's going to be pi r squared, because that's the formula for the area of a circle, as we see in MYP2. So r squared is just the radius times the radius, and the radius here is 13. So I'll just write pi times 13 times 13. So the first bracket there gives us the square area, and then the second bracket there gives us the 3/4 of a circle area. So when you work that all out, it comes to 676 meters squared for the square bit, and then 398.1969, can round that as far as you like, meters squared for the 3/4 of a circle. So we'll just add those up, and that comes to 1074.1969 meters squared. So the volume is the end area times the length. So that's that 1074 and a bit that we just worked out, meters squared, times the 43 meters, which was the height of the building. And when you work that out to the nearest meter cubed, as required in the question, comes to 46,190. So I've just put that in the box in MyiMaths. Then we're looking at the next question, which is about a greenhouse. And you can see it looks like a prism where the end shape consists of a combination of lots of squares, rectangles and triangles. So I'll just draw that out. Okay, so I've just drawn that out, and I've written out the different bits that we have to calculate to work out the whole area. So we've got 2 rectangles there that are the same. They're both 0.9 times 0.7. So I've got 2 times 0.9 times 0.7 there. I've got 2 that are 1.4 times 0.7. So I've written 2 times 1.4 times 0.7 there. Just do that again. I've got 2 that are actually squares, 1.4 times 1.4. So that's 2 times 1.4 times 1.4 there. And then I've got a couple of triangles here that are identical. They're 0.9 width and 1.4 height. The area of a triangle is half times base times height, but there's two of them. So that's here where I've got 2, because there's 2 of them, times a half times the base times the height, 2 times a half times 0.9 times 1.4. And then finally I've got the 2 at the top, which are identical, or reflections of one another at least, and they're 1.4 in width and 0.9 in height. So each of them is 0.5 times 1.4 times 0.9, half base times height, but then times 2 because there's 2 of them. So when I work out each of those brackets, I'm getting 1.26 plus 1.96 plus 3.92 plus another 1.26 plus another 1.26. And when I add them all up, I get the end area being 9.66, and that's in meters squared. So the volume that we're looking for is that end area multiplied by the length of the prism, which was 13. So we've got to do volume equals 9.66 meters squared times 13 meters, which comes to 125.58. So we'll just put that into MyiMaths. So we needed to do that to the nearest meter cubed, so that's 126. We'll mark it, and 6 out of 6.